So, good afternoon, good morning, ladies and gentlemen. Welcome to the Fluitec webinar today entitled The Value of Integrating Ruler and MPC for all your oil monitoring programs. My name is Ameye from Fluitec. Today I'm pleased to be having my two colleagues, Guillaume Calfon from the Middle East and Filippo Colucci from Europe. They will be my co-organizers for this webinar. Just to help you understanding how this webinar is going to be organized today is if we have any questions, you can fill in your questions on the Q&A section, which you can find on the left upper side of your screen. Then I will stop from time to time asking my colleagues if they can list me some of the questions. After 45 minutes maximum, we will have another good 50 minutes time for responding any questions you have. So I think I would like to start now on time. If we can make sure that our micros are muted, Guillaume and Filippo, to have no background noise. Thank you very much. So welcome again, ladies and gentlemen, to this Fluitec webinar. I hope, and we all hope at Fluitec, that you are in good health, given the difficult circumstances we are going through. I believe that at Fluitec we have taken some time to help you and share some insights, technical insights we have from more than 25 years of field experiences into the condition monitoring industry. So today, specifically, we want to cover an agenda as following. We are going to discuss specifically oxidation and antioxidants. What does that mean today in an industry? We will then specifically talk about LSV technology and MPC methodology, how they are enhancing your programs. We'll briefly take a helicopter view on what the needs are today for condition monitoring programs and the value of ruler and MPC or LSV. We will extend to what OEMs today and standard organizations look at these new methods. And then surely we will take plenty of time to look at different applications and case studies specifically to share information with you. So yes, the question is, why do we want to speak today about oxidation? Like we say here, it's one of the top nemesis, and together with wear. So wear and oxidation are two main degradation patterns of in-service lubricants. And as you may know or not know, virtually every lubricant in service will experience from oxidation. The speed of oxidation is really depending from, for example, heat. Think about the Arrhenius law. Every 10 degrees C increase of a fluid will just halven the lifetime of your fluid. Contamination, absolutely. Think about some of the catalysts like copper, iron, accelerating oxidation reactions. Reducing absolutely lifetime of your in-service fluids, impacting reliability of equipment. Think about what happens with the oxidation products. Where will they go? Are they going to stay in solution? Will they form deposits, which we will then cover later? And last but not least, today certainly in the aspect of saving the environment, it is also impacting the sustainability aspects of our lubricants. When we have live seminars, unfortunately not today, we look forward to having soon back live seminars. Very often I receive the question, what is now oxidation? And during those seminars, I usually take an apple in front of my desk, take a big bite into it, and then let it stay for half an hour, and you get the results. This is oxidation. So you're having a reaction with air or oxygen if you want. Another good example of that is iron and rust as an oxidation between iron and oxygen. And or you can think about your any tire, which is also going to harden and then become oxidized. So it's surrounding us, absolutely oxidation. Another severe result of oxidation is this picture I like to share. Absolutely, you don't want to wait that long, but yes, oxidation can also result into increased cross-linking of your hydrocarbon chains and then create this high viscosity increase. It makes me remembering my first maintenance director in my first job telling me that when we needed to follow up oils, he told me just look, smell, and feel the oil. Um, Times have changed absolutely. So again, with modern lubricants today, you will not see this viscosity increase, but just as a symbolic for you. So let's talk about oil health care. We know that for protecting the base oil of any type of lubricant in service, antioxidants are a critical additive. They are going to make sure and ensure that the lifetime of the lubricant is assured. And to make a comparison that we often make, antioxidants is just like this apple and the apple skin. What is inside of the apple has to be protected by the outside. And that's the same for your lubricant. So the base oil needs to be protected at any time by the antioxidants. There can be a mixture of antioxidants, different type of antioxidants working in synergy. And why do we use this picture? Is just to visualize you what type of oil lubricant in what state you want to use it. I have made my decision when I see a picture like that, and I'm sure you also do that. So the similarity to a human body is quickly made. And to help you understand, and I don't want to do too much chemistry today, but still I want to show you the oxidation propagation cycle. Look at this graph by starting this at this point here where you see the hydrocarbon chain. It's the initiation of the oxidation. It will react with oxygen in the environment and create what we see here, the free radicals. You see the little dot, that is the electron, the free electron, which is a lot of, is very reactive, and it's like a chain. So it is a chain reaction which is propagating all the time, making also then free peroxy radicals. And if you do not stop this reaction, you will continue to produce free oxidation radicals, and it is going to be up to the antioxidants to be responsible for stopping, or if you want, terminate this cycle of auto-oxidation. And that means that antioxidants in a process of lubrication are sacrificial. They will be consumed. It is very normal that you will see this consumption of antioxidants. So monitoring at any time the oil health means monitoring also the antioxidants. I promised you that I wanted to show you a graph on the impact of temperature. Equipment today, not only by the size of the oil reservoir, but also by its design, also are seeing higher temperatures. This is a graph you can see from an evolution of a gas turbine with their higher firing temperatures. You can see that typically that means that the bearings or the metal components lubricated will also see higher temperatures, knowing that the number one characteristic feature of a lubricant is to dissipate the heat or cool the metal surface. So you can conclude from that that lubricants today will absolutely be faced with higher temperatures. If we then take a helicopter view on, I would say, more than 100 years of oxidation tests, we could present it by this graph. So in the early years, asset number was developed as a test method to really look at the results of oxidation. I would say mild oxidation, most probably, looking at the working conditions, and was at that time a good test method until the mid 1900s, when there was more and more the use of steam turbines, requiring development of the oxidation performance test, the RBOT at that time, and now it's called RPVOT as an oxidation test method. Until then, early 2000s, with the appearance of new formulations, newer base oils, and also more use of gas turbines, there was a direct need for antioxidants measurement, which is then covered by linear sweep voltammetry, or if you want, also FTIR. So linear sweep voltammetry, the word has fallen now, commercially known as the ruler, standing for a technology that is measuring directly the amount of individual antioxidants. Comparing to FTIR, you may see that if LSV will not be masked by, for example, an ester base oil. So ruler stands for, when you perform this technology, measuring at any time the remaining useful life of your lubricant. Any type of lubricant that contains at least one type of antioxidant. And trending this antioxidant depletion will give you then a clear view how your antioxidants are behaving under these specific operating conditions. Without wanting to go in much detail on this LSV, it is a comparative test method. As you can see on this graph, we will compare fresh oil, which is the upper green line. That's the 100% of antioxidants. And you will compare the red graph, which is the in-service oil, with the two antioxidants you can see here. And by comparing area to area, you can then see how individual antioxidants, in this case aminic and phenolic antioxidants, are depleting. For your information, these technologies, LSV is covered by a wide range of ASTM test methods, depending from its application, greases, turbine oils, automotive oils, and also supporting practices more or less for in-service oils like hydraulics. And I will come back on that later when I talk about standard bodies. Linear sweep voltammetry is an electrochemical test method. What does that mean? We are going to detect the remaining activity of the antioxidants by measuring the remaining activity of the functional group of the antioxidant. a long word. What does that mean? A functional group of the antioxidant is that group specifically that will be able or has the capacity to neutralize these free radicals. Once it has reacted, remember it's a sacrificial additive, once it's reacted, this functional group cannot react anymore. And that is what LSV is electrochemically measuring. And by applying a short test in 17 seconds, you're able, by applying a linear voltage increase, you can create an oxidation reaction. So the red line is the oxidation reaction wave peak, if you want. And what we do by this graph, or what we achieve by this graph, is that the time of the appearance of the antioxidant is telling us the type of antioxidant, because we are measuring the different functional group. Think about the zinc that here phosphate, or an amine, what is NH, or a phenol by its OH group. And the area, or the peak height, if you want, is related to the remaining activity of the specific antioxidant. LSV, for the simple, I would say, for simplicity and also for ease of use, is able to detect a wide range of antioxidants that you can see on this in this column. A wide variety of antioxidants, depending from its application. I think, give an example, if you have like an amine in a polyester for jet engine oils, or if you have a ZDP in an aminic mixture for combustion applications, you will be using different test solutions, because the electrolyte is going to be binding the specific antioxidant during the reaction of the electrochemistry. Do we have any specific question on LSV, Filippo or Guillaume, before I continue with talking about MPC technology? Okay, good. Well, I will then continue to save time. So now that we have spoken about LSV as a first approach to condition monitoring, why is it that at the same time MPC is such a good combination, useful combination with LSV? We have to go back like a good 15 years, 2004, 2005, with the appearance of optimized oil formulations with specifically group 2 and group 3 base oils into hydraulic fluids, RNO formulations, compressors, gear oils, which are resulting in an extended lifetime of the fluids because they have a higher oxidative protection. At the same time, we noticed that the way they degrade and during oxidation or thermal degradation, that the contamination buildup is very different to a group 1 oil. This is referred to what is, you certainly, some of you will know, it's the varnish tendency, which let us understand that in different research programs. For example, this research program was presented at ASTM Symposium in 2005, where about 10 oil formulations were oxidized, and doing this oxidation cycles, you see from 1 to 8 cycles, we see that there's a constant increase of the MPC value. I'll explain just in a few minutes MPC value, but just see from this correlation is that where RPVT and aminic antioxidants have a similar depletion trend, and let's say not very high, we can see that in opposite to that, is that from the same type of lubricants, that the phenolic antioxidants have a definite different depletion trend. And if you look well, you can see that the orange depletion is nearly opposite relative to the increase of the MPC. And that has to do 100% with the contamination buildup due to solubility issues with the newer oil formulations that needs, of course, to be addressed. So by 2000, mid 2000s, there was the MPC method, which stands for a membrane patch. It's a patch test applying colorimetry and covered by ASTM methods D7843. It's a wide today. It's although it was initially developed for turbine oils, it is a widely developed test for used by commercial laboratories, research laboratories, and helping to indicate the amount of oil degradation products, insoluble, soluble content into a wide range of fluids. The MPC process consists just of mixing 50 milliliter of oil with a specific solvent, extracting the soluble and insoluble material, and then filtering it on a patch of 0.45 micron, creating these typical patch examples. The intensity, the color intensity or the hue intensity is used for quantification of these colored bodies, like we call them, insolubles. And the level is using also different categories. So we say that between 15 and till 1520, you are in the normal level of soluble or varnish content. Above 20 till 30, it's better to monitor closely the fluid, and everything above 30 starts to be abnormal, from 40 critical, and as you can see from these patches, we can go even higher than 50 in some cases. The intensity tells us how much quantity you have. Also, what is good about the MPC method in correlation with LSV is that the color identification of the patch learns us also a lot of information on the possible root cause of degradation. And one of the root cause, possible root causes is accelerated depletion of antioxidants, which can be caused by excessive oxidation or thermal stress, and creating then some of these insoluble products. One point I really wanted to mention, and I would like to thank our partners from Ocean Team in Qatar supplying us this information, is that very often we receive the question, yes, my oil is very dark, it must be in bad shape. It's certainly not a good conclusion, and it's not conclusive, the color, let me say it like that. And it's certainly not necessarily related to the varnish potential. As you can see on this typical slide, we see here on the right side the lighter oil producing a higher MPC patch. And this is now exactly what it means, that these compounds, they live in the oil, in some way it's soluble or in solution or not in solution. And it's going to be important to understand, and I will come back on that later, how these fluids are degrading and understanding the degradation pattern. Understanding.
Yes, you can hear
yes.
me? Okay, sorry, I had a little problem before with the mic. Just first to inform that unfortunately few people cannot hear the presentation, can see that, but cannot hear the presentation. There are several of them already. And I think this is the platform that is creating maybe some problem with some browser. But okay, besides that, I have one question that was about before, so I should have before, but unfortunately I can't now. And then it's about RPVOT and voltammetry. So, which are of course two different methods, and they want to know if these methods can complement each other to have a better information about the oil condition. I said yes, they are not the same methods. They give two different information, but maybe you can explain better.
I think with they can be complementary. What we see is that RPVT is more can be a test method for development of new oil formulations, whereas in-service testing is more applied by LSV because of time and accuracy, and secondly also the individual antioxidants monitoring that you cannot achieve with an RPVT, and it will be very valuable for root cause analysis and degradation patterns identification, which I will cover later.
Okay, and then we have a question about the MPC test. I let you reply, I know that, but how long from preparation to analysis? I know that normally we ask for about 72 hours, but I guess the most important thing is repeatability of the test. So if you perform at the same time, so in the same way, oh, we lost you, I guess.
No, I'm cutting my video because I think you should also cut your video because that may increase the quality of the presentation.
Okay, can you hear me? Yes.
Yes, perfectly.
Okay, so it was about the time between the samples taken and the test.
For the test, which test method? Which one?
MPC.
MPC. That's a procedure that you need to. I think we need to refer to another webinar, but I will shortly answer that. It's 24 hours heating up the sample to zeroing, and then 72 hours cooling down. That's the standard procedure.
Yes, but question. You have a question from my side as well. But this is most important that you repeat in the same way, not the test. So if, for example, you take the test after 24 hours, and instead of waiting for 72, okay, the values are maybe
no. You have to, and then we continue. Otherwise, we have too much delay. We have to cool down the oil after 24 hours heating up. You have to wait 72 hours cooling down to make sure you're gonna measure accurately the insoluble and soluble contamination. Absolutely, good question.
Okay, good, thanks.
So correlation between LSV and MPC, this is a good example of a fluid turbine oil stressing out for several weeks, where we have a mixture of aromatic amines, alkylated PANA with diphenyl amines and phenolics. And you can see that when stressing the fluid over several weeks, that's the some of the major antioxidants are depleting first, followed by the second antioxidants. What does that mean from this perspective? It doesn't tell you very much, but if you correlate then the depletion of this first main antioxidants, you can see that it translates us in the behavior of the oil in respect to the MPC. We can see that sample 2, which is after one of the major additives has gone or has been simply depleted, that then after just at that moment, you see an increase, a significant difference and increase in the MPC value. Another good value of LSV and MPC in combination is understanding how turbine oils will have a different degradation tendency of varnish formation in function of its formulation, but also in function of the turbine, its application. We see here, for example, two different turbines suppliers and with totally different varnish tendency for the same oil formulation. Look at oil C, comparing, where you can see that there's a really much lower varnish tendency on turbine B. So clearly LSV, MPC, they are helping to combine and result in a lot of added value. And the reason is, why would you do that? The answer is here is what you can't, what you don't measure, you cannot manage. I love this one-liner because I received many times the question from end users, why should I include this test methods? And I'm sure there's attendees from laboratories in this webinar who received this question. And the needs today, the latest needs for condition monitoring programs is that the emphasis is moving certainly to understanding the fluid degradation and its failing point. And you're not going to wait too long to take the right corrective actions, especially to prolong the fluid life. And also, if you understand better the fluid degradation, you're also able to establish a customized condition monitoring program in a much more appropriate way. And last but not least is that today with sustainability requirements, it's important to really understand in a more detail how fluids are degrading. And why do you want to know that? Because I love to use this graph from my friend Rudiger Kreta at Ulcek, where he divides the graph of lube oil in three phases, and the induction phase is where you want to stay at and monitor the oil and avoid that you start to see this build-up of free radicals, acidity, and the sludge. So in essence, if you can stay in this area, you're able to control your base oil and your fluid and much more safer the fluid life. So that means that beside contamination control, like particle contamination, wear analysis, oil degradation is important to understand from a contamination perspective, like MPC, ultracentrifuge, FTIR, but also be in a position to relate that to what stage of the oil cycle life you are, how much of these antioxidants have depleted. And this is, for example, typical oil matrix for compressor oil, where if you're able to perform this matrix by looking at soft contaminants, contamination, as well look at fluid degradation, and last but not least, the compatibility with contaminants. And what do we understand with compatibility is not just understanding what is going on with used oil, but are you cross-contaminating a new oil with existing contamination from an earlier batch of oil? Or, for example, are you mixing oils which are not 100% compatible? That will have its impact immediately on air release, foaming, and emulsibility. So this is as an example of a very performant matrix where, again, LSV and MPC play a major role. If we have a look on OEM and standard test methods, how have OEMs today reacted after, I would say, looking in the last 10, 15 years and the standard test bodies, then we can see that there's a clear evolution from major OEMs like Siemens Energy, Ameye Energy Solutions, Solar, Atlas Copco, where LSV, antioxidants monitoring, and MPC are part of the standard recommendations or even their own oil monitoring programs in order to better support their customers and increase the reliability of their equipment into the field. And we can also see that today standard test bodies like ASTM, VGB, looking at including also these test methods to be part of the right guidelines for end users of this in-service fluids. I've added another interesting practice of ASTM. It's D6244, which is more used for auxiliary equipment like gears, hydraulics, phosphate ester systems, and all of them really highlighting also the guidelines and condemning limits, action items for this So we have a good 10 minutes left to talk about some of the case studies, and then we are open for some questions. When we presented or prepared this webinar, I tried to bring as much as possible case studies. Unfortunately, the time is limited, but just to give you a view on where today direct AO or LSV and MPC testing can be applied, it's going from turbine compressor hydraulics over greases, gear oils. I've not included today case studies on greases, nor on transformer oils or transmission fluids, or on wind gear, turbine oils. But yes, I see, for example, this afternoon there is a session from MRG in the US specifically talking about grease analysis, including LSV. So let's focus on some of the application. The most obvious one that most of you who are attending this webinar will know this. It's turbine oil, where you are trending antioxidants like individual amines and phenols. And what I really want to emphasize with techniques like LSV and MPC, if they are part of your oil monitoring programs, is that you need to follow up by trend analysis. It has no sense to look at one data point and really only measure one set of data. In this graph, for example, you can see very well how you are trending and correlating the most important parameters and showing different operating conditions. That is the real value of these techniques for as part of condition monitoring programs and trending. Another case is the compressor oil, where you see the blue line is the MPC value going initially from 50s going to level less than 10. You see here on the X scale. The secondary scale is showing you the antioxidants level, and we can see that at this point when the level of 40% is achieved, in this case you still have a lot of margin, because safety margin, because usually 25% is the condemning limit. Still here, the oil was re-advertised, and you can see that the lifetime is then again controlled in combination also with the control of MPC. So here, good example of LSV and MPC. An emerging market today for LSV and MPC oil analysis is hydraulic oils. Think about markets, marine injection molding, mining, steel. With the new use of base oils and additive technologies, lower oil volumes and higher operating temperatures that we see, issues like on this servo valve, as well pump failures. Where does it come from? It's also a lot of oxidative stress happening on the fluids and resulting in deposits on the valve components, as you can see here on these two pictures. Knowing that with LSV, you have an ability to look at a wide range of additives, even the antioxidant property of a zinc dithiphosphate, knowing from engine oils, but also used as an anti-wear antioxidant for hydraulics. And I think I tried to show you I will show you a few cases where MPC for hydraulics as contamination control in combination with ISO particle counting and LSV, like on this hydraulic press, where we can see there's still a reasonable, a good life, 65% of antioxidants, but an MPC which is in the range of 66, which is of course much too high, knowing that in this case it is not because of the fluid who was not behaving or not having good behavior. No, it's just because there was a cross-contamination from an older oil into the newer oil. So more cases from hydraulics here, a correlation between MPC values. You see 74, rule number of 10, and look at the particle count 22, 16, 13. typically indicating that you're accumulating these small 4 to 10 micron soft contaminants which are agglomerating and forming this MPC. Another case study here, ruler number really low, 0% high MPC value. Of course, I don't have to tell you that in these fluids, you're far beyond, I say, the useful life of the fluid. And wouldn't it be ideal to pick up this information before you're getting in this level of oxidation? A good example I have received also from Olczek from a presentation we did together. I remember it's on a paper mill, paper machine oil from a cylinder, lubricating of a cylinder, suffering from a high water increase. You can see it here, the water increase resulting shortly after that with iron, copper increase, washing out the sodium. And if you then look at these samples, how the ruler graphs are looking, we can see that, in fact, the last sample here was having 0%. So a very sudden drop of antioxidants just because of oxidation, and clearly before even acid number is further increasing. So it would be wise here to take an action before you continue to run in these conditions. Diesel engine oils, less, I would say, a market for MPC because of their own detergency. It's still interesting for LSV. More complex formulations you can see with mixtures of antioxidants from amines over to phthalates and phenols. Trending very well also on this field trial, and up to 78,000 kilometers, this engine oil was showing a very steady depletion of antioxidants and stable TN, TBN value, and not any iron increase, showing that there was still good oil left in lifetime left into the oil. As a combustion application, biogas engine, it's also an emerging market here in Europe. And by biogas engines, because of the inherent combustion reaction, higher combustion temperatures are using a quite high concentration of antioxidants. We see here a good trending graph of antioxidants depletion on biogas engines. Interesting on this case, and I would like to thank again Olczek for supplying me this data, is the trend with viscosity and base number and acid number, where viscosity is starting to reach its limits. Base number and acid number is still acceptable. We can see that the depletion of antioxidants shows a much better correlation towards identifying the lifetime of the fluid. And as you can see here, the fluid was changed at 2,200, and the real lifetime should have been around 1,700, which is for a biogas engine quite important, avoiding to produce deposits. Talking about synthetic fluids now, briefly, we can think about polyolesters on jet engine oils, gas turbines, industrial gas turbines, in this case, roller bearings protection on helicopter, suffering from coke deposits formation. And we can see that when we looked at MPC, not only we see a very high MPC, far above the limit, but also production of these agglomerates, varnish agglomerates into these esters, although they have a very high solubility. And when we think about synthetics, we specifically think about ester-based fire-resistant hydraulic fluids, like we see on this steel plant, where also valve were suffering from deposits confirmed by a very high MPC level, and still, I would say, around 50% life of antioxidants. And last but not least, for us, I believe the market where today we see also more and more need of MPC and LSV as part of condition monitoring programs are the electrohydraulic control fluids for servo valves, where LSV has the ability in a reverse way to be used, that you're not depleting antioxidants, but you're making or picking up phenolic production because of hydrolysis. Phosphodesters, they react with water, they hydrolyze, and they make these free phenols. And what we have noticed is that although you see that the fluids appears to be in good condition, that the hydrolysis is creating a lot of phenolic alcohols, which then can further oxidize and then form these deposits suffering the valves. You see here this test had an MPC of 54 with very high production of, as you can see on the right graph, the ruler number coming up extremely high from the new oil versus the higher acid number, helping us to understand that this oil should have been treated and just avoid the buildup of the acidity. We are 45 minutes gone, so I'm in my last slide. I hope that from this webinar you will have learned that there is a good potential in monitoring antioxidants for a wide range of lubricants, as long as I say they contain one type of antioxidant, both in thermally and oxidative stressful working conditions. LSV and MPC are, I would say, partners. They give you very good information in combination. And remember that LSV is today also a very strong tool for quality control of your implant storage fluids, root cause analysis. And so I would like to thank you for your time. If you are interested in more of these webinars, then you can subscribe at info@fluitec.com. We will continue to organize these webinars. I apologize if you had some noise or quality problems, which is, like I say, probably due to more issues with the platform. And good, I am ready for answering your questions. If there are a few left here, we have 50 minutes. Guillaume, Filippo, you can launch your questions if there's any.
You have a couple of questions here. First, thank you very much. I mean, it was an amazing presentation as usual from you.
Thank you.
One is about the MPC, which actually I'm interested as well about the replies, because I'm not sure about. So if we have some dyeing, some like a tracer in the oil, like in a turbine system, is the MPC still valid for dyeing?
Yes, it will just. You don't forget you dilute the oil into this petrol ether or these N-heptane, which is going to then work on the polarity and apolarity differences. And what remains on the patch is just these agglomerated organic, inorganic contamination dyes or fluid of the oil that just pass with the oil phase. It's going to be important, of course, like in any MPC test, is I've done that in several laboratories, is to make sure you clean your patch, and also the procedures mentioned that you use around 30-40 milliliter to afterwards rinse the patch to make sure there's no remaining oil contamination, just oil, pure oil. So that this is not influencing your MPC value. Absolutely.
Okay, thank you. And then I'm not sure, he's asking, is there any mobile measure equipment that gives reliable values? And if yes, which equipment is that?
Well, The MPC test, I guess it's about MPC test. The question is about because ruler and MPC, a ruler is a mobile equipment. It can be used anywhere. LSV, MPC, I would say it's, for my opinion, it's a lab equipment test because you're working with solvents. You need to have good vacuum pressure, the right vacuum pressure. It's not just a test you perform quickly. It needs a good attention and to avoid reproducibility problems. You need to heat up the sample also. So I don't think it's really a mobile. Of course, there are mobile trucks, service trucks, and that can be done. Then that's a different condition. But just pure mobile, meaning doing it on the field next to the equipment, that's a little bit of another challenge. I would not recommend that for this test method.
Okay. And then a question about the ruler test. Is it important to have a measured 0-hour reference measure?
It's always important with voltammetry is that we also recommend that because this is a good question. The reference sample is key to ruler interpretation. So either the laboratory is using or the end user is using its own database of standards, the 100% reference value, absolutely. Outside of that, what we recommend in our procedures is that it is important to regularly measure the new oil because it could be that oil formulation have changed. It can also help you to detect storage problems when you have not stored your lubricant correctly, or even not so very often, but that maybe you received a wrong delivery of a fluid. That you can verify the quality. So yes, the standard is important that you're sure 100% certitude that this is your correct reference, because all results afterwards that you use and you will trend will depend from that just one standard, and therefore spend time on selecting the right standard. And I can confirm that when we organize trainings at Fluitec for laboratories, and also today with a lot of our customers, we continue to share and help them in using the right standards. It's a good question and key to be respected.
Yep. Okay. Very good. We have one more question is about if you test the turbine oil with LSV and MPC, do you still need to run RPVOT too?
No.
I think it's I think it's maybe at the end of the presentation when the presentation will be available for everybody. Maybe we can send a list of tests which we recommend always to have on the oil.
Yeah. Well, no, RPVOT for used oils today. I'm just looking at the feedback I have from RPVOT on new oils. The new generation of oils, the issue is some of these RPVT values are so high, like 2000 minutes and higher. Imagine for a laboratory to perform a test of 2000 minutes compared to an LSV 17 seconds. I don't have to make a signature here. It means clearly that the speed of test compared to an RPVT, what does not mean that it can still be used, but complementary. I would think about the convenience of testing speed, time, and also the individual antioxidant information. And if you really have to follow RPVOT by OEMs, which today is not the case because the majority or most of the OEMs today and also ASTM and DIN standards, they offer to use both tests. They don't exclude any of them, so or exclusively specify one test, so, which was 10, 15 years ago was the case, where only RPVOT was the test method. And I think that's what today the industry is still a bit confused. I understand this question because there's still maintenance procedures out there which are not being updated and still mention RPVOT, where if you look at the latest, ask your OEM or your equipment manufacturer, ask their latest O&M manual, which is then also referring to standards, and then you will see that these methods are updated, and it mentions LSV or MPC or RPVT in the correct way.
Okay.
I'm looking here myself here. Yeah, I apologize. I don't know what's going on with the sound, because I can hear everything correctly here. So the presentation will be made available, so you can send me an email if you don't have heard the presentation correctly. We will then forward you the presentation